This is question 3 from the first CSAT sample paper. So in this question we're given an isosceles triangle, and it's these two sides that are equal, so AB and AC. And we're told we draw a circle whose diameter is AB, so the centre's on AB in the middle and the radius is half of that side. And then we could draw the whole circle, but I've only drawn the right hand side because that's the only bit we care about. If we draw that circle, it intersects the side BC, so that's the side that isn't equal to one of the other sides. And it intersects at a point P, and what we're asked to do is to find the ratio of BP, so this length, to BC, so that's the whole of the base. So if you want to have a go at this question yourself, pause the video now. Okay, so what's the best way of thinking about this? In general, when you have circles, you often want to use facts about circles. Well, what facts have we got? So for instance, you might think about the fact that the tangent is at right angles to the radius, but we don't have any tangents, so we're not going to use that fact. We could use the angle in a semicircle as a right angle, but that's not obviously related to the triangle. How about the most basic fact about circles? All the distances to the origin are the same, they're all the radius. Not to the origin, sorry, to the centre. And we might think about drawing, well, that line's not so interesting, but this one, that might be interesting, because that links P to the circle. That relates P to the circle and to this side. So we might draw this line and think about what that means. And then the thing to see there is that gives us similar triangles. So we can do this question using similar triangles. So let's draw that line and see what follows. Okay, so here I've drawn that radius from the centre to P. And that side is also length R, and this is length R, well, that's the radius of the circle. And the thing now to see is we've got this little triangle in here, OBP, and that turns out to be similar to ABC. Why is that? Well, they're both isosceles, and they share this angle at B, and that means this angle here has to be the same as that angle because it's isosceles, so this angle is the same as that. That means this angle has to be the same as that. So they have the same angles, and they're both isosceles. So they're similar. So what's our argument look like? Well, we say this is isosceles, we say this angle is in common, and you could go through saying the other angles are equal, but it should be clear that's immediately enough to say they're similar, because once you have an isosceles triangle, the shape of the triangle is completely determined by one of these angles. So that means these two triangles are similar. How does that help us find the ratio? Well, it means once we know the ratio of one of the sides of this triangle to one of the sides of the big triangle, that gives us the ratios for all the other sides. And one of the ratios is easy because this side here is exactly half of this side here. So the triangles are similar, and we know this ratio of OB to AB is 1 to 2, because this is one radius and that's 2 radii, that's the diameter. And that means that this ratio of this to this has to be the same as well. So that has to be 1 to 2. So our answer here is that the ratio of BP to BC is 1 to 2.